While the Internet was in its infancy, monitoring traffic was relatively simple. However, after experiencing phenomenal growth in the 1990s, tracking connectivity has become a daunting task. Recently, CAIDA researchers have attempted to strip away lesser connected autonomous systems, or ASs, in order to find out how Internet connectivity is distributed among ISPs. This research led to CAIDA's first AS core network graph, which is derived from 14 sources to over 150,000 destination IP addresses during a 2-week period in mid-January 2000. It includes data from CAIDA's Skitter monitors and Bill Cheswick's Internet Mapping Project, which includes 374,000 links and 220,000 total IP addresses, including intermediate nodes. Here's how it works. The path information is aggregated into a topology of autonomous systems, each of which approximately maps to an Internet Service Provider, or ISP. This abstraction occurs by mapping each IP address to the ISP responsible for it.
AboveNet, 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 Quest, Quest, Quest.
Over 200,000 IP addresses are aggregated into less than 5,000 autonomous system nodes. These ASs are filtered further by recursively removing leaf nodes, nodes with only one connection. This leaves about 1,500 ASs, representing the most richly connected ISPs in the dataset, or what we define as the core ASs. CAIDA's AS core network graph has a geographic structure that views the Earth from the North Pole. This allows mapping of longitude to the circumference of the graph. Continents can be identified based on longitudinal position, with large cities labeled around its perimeter. An AS node's radius from the center of the graph, as well as its color, reflect the out degree of that AS. The out degree of an AS is the number of other ASs that accepted traffic from that AS. Furthermore, out degree counts only outgoing connections. The position of each AS node is plotted in polar coordinates. Again, the radius from the center of the graph indicates the richness of that AS's connectivity to other ASs. The polar angle of each node places each AS geographically by the location of the ISP's headquarters. Note that multiple ASs may reside in the same city. This visualization is important as it is a preliminary step in illustrating relationships and determining critical components of the Internet infrastructure.